In April 2025, NASA issued another warning. A filament eruption on the Sun will hurl massive amounts of particles toward Earth, and we will experience a solar storm here. The solar cycle will reach its absolute peak this year, and many experts and concerned citizens are wondering whether the long-predicted horror storm will come. If it does, our civilization could be plunged into darkness within minutes, causing chaos and enormous damage. In April 2025, we will be approaching the peak of the current solar activity. A geomagnetic storm warning of level G2 is causing concern. The reason for the warning is a filament eruption with a coronal mass ejection, which was first observed by astronomers in mid-April and could have critical consequences. The ejection produces large streams of particles that flow toward Earth and can cause various disturbances here in the following days and weeks. An ejection of this intensity can also be the prelude to further solar activity, causing more and more severe storms and problems. Current sunspot activity gives cause for concern. What can we really expect in April, and what will the rest of the year bring? We're currently experiencing high solar activity, and the current sunspot count is at an alarming level. However, we have not even come close to reaching the peak of the current solar cycle. We will not pass through this critical phase until May and the end of summer 2025. So far, around a dozen violent X-ray flares have been observed, some of them among the strongest since records began. Several M-class eruptions, large filament breaks, and subsequent coronal mass ejections have led to extremely elevated proton levels. Much of the Sun's activity has significantly exceeded warning thresholds over the past year. Simply put, for over a year, we on Earth have been experiencing a particle bombardment unlike anything seen since modern solar observation began. It all started with an event on September 15, 2023. At that time, a coronal mass ejection heralded the beginning of the current peak in solar activity. The plasma cloud that was released at that time reached us a few days later and triggered a moderate geomagnetic storm and some disturbances. The event was officially classified as a G2 level geomagnetic disturbance, very similar to the storm we are currently experiencing in April 2025. The level can still be described as moderate. The G2 storm of 2023 triggered auroras that were visible in several U.S. states, including Alaska, Montana, North Dakota, Minnesota, Wisconsin, Michigan, Maine, and New Hampshire. In addition, minor disruptions, such as brief outages in communication systems, radio problems, and GPS blackouts, were reported. The disruptions were minimal in duration and were easily overcome. But what happens when a more severe storm hits, and systems like these are severely disrupted for hours or even days? Compass errors, power outages, and confused animals. Can you imagine a scenario in which the power is out for days, your cell phones no longer work, and confused birds fall from the sky? That's exactly what could happen if a long-predicted horror storm hits us. The list of countless warnings includes navigation disruptions due to compass errors, GPS deviations of up to 10 meters, power outages caused by transformer malfunctions, disrupted satellite communications, and, as a result, failures in television broadcasts, radio and radio communications, as well as navigation systems in cars, ships, and, in the worst case, even airplanes. The chaos in the airline network would be catastrophic, with airlines having to cancel flights en masse at the first sign of significant disruptions, and aircraft in the air having to land immediately at the nearest available airports. The scenario could have another drastic effect. Some researchers suspect that it could cause severe disruption to wildlife. Animals that use the Earth's magnetic field for orientation could lose their sense of direction. Birds, fish, bees, whales, and probably all other wild animals are at risk. Foxes and wild boars could stray into cities. Birds could make emergency landings in large numbers and then gather on roads in parks and other unusual places. The scenario is somewhat reminiscent of Hitchcock's horror classic The Birds and Other Apocalyptic Visions. The nightmare would probably be over after a few days, but it's impossible to predict what damage would have been done by then. Power outages could cause serious problems for security systems and food distribution. ATMs could be blocked, and shopping facilities would only be available to a limited extent. It's impossible to predict how bad the scenario would be in the event of a horror storm. We have never experienced it before, and we do not know how secure our systems of emergency power generators and other backup systems are. Experts have warned of another danger. Induced electrical currents can overload transformers, cause short circuits, or lead to fires wherever electrical cables are not laid in accordance with safety standards, as is the case here in Europe. The 1989 blackout in Quebec, Canada showed that a moderate storm could paralyze the entire power supply of 6 million people for 9 hours. During the Carrington Event in the 19th century, the still young global telegraph systems failed. Wires melted, sparks flew from electrical equipment, and set paper on fire. Ultimately, the greatest modern danger is the cost. Even minor outages can cause billions in damage. The cost of weather navigation and communications satellite outages alone would run into the hundreds of millions of dollars. Diverting flight routes over the equator during severe solar storms could push many airlines that are already struggling to remain profitable to the brink of ruin. The Carrington Event of 1859. Points of comparison. In September 1859, no one could have guessed what was coming. People had only just become accustomed to the convenience of electric telegraph transmissions. Electrical engineering was still in its infancy, but the ability to transmit messages around the world in near real time was something like the first globalization and the beginning of the modern communications age. At that time, researchers were already interested in the sun, but no one knew anything about the exact connections between the Earth's magnetic field, solar activity, the aurora borealis, and the fledgling power grid. Electric current has brought us progress and shaped the culture we enjoy today. The Carrington Event is now seen as a warning to humanity. It all began when auroras were seen in regions of the northern hemisphere where the phenomenon does not normally occur. Some eyewitnesses later reported that the sky was ablaze. The Midwest of the U.S. was particularly affected. There, sparks suddenly flew from telegraph equipment, and some telegraphs began to work independently, as if moved by magic. Where this happened, people thought it was a haunting. Where sparks caused paper fires and telegraph lines buzzed and crackled suspiciously, people suspected a defect and an overload of the power grids. What had happened? Our Earth's magnetic field normally intercepts electrically charged particles from the sun and traps them in a kind of safety net. The collection pockets for the particles exist at the north and south poles. When they are full, we see colorful swaths of light due to the swirling of the particles and their interaction with the Earth's ionosphere. When these collection basins are overloaded, the particles from the sun are pushed further south or north, and the aurora borealis becomes visible in areas where it is not normally seen. In 1859, the lights must have been enormous because they were visible in broad daylight, and the air was literally crackling. The crackling was probably caused by particles that migrated deeper and deeper into the atmosphere due to the overload of the Earth's magnetic field. Imagine such a scenario. You wake up in the morning, the sky is glowing, and sparks are flying around you from cell phones, power outlets, and other technical devices. Outside your door, you have the feeling that the air around you is crackling, and perhaps the fine hairs on your skin are standing on end. In 1859, many of the then still quite superstitious people thought that a curse from God had befallen them. What actually happened was a solar flare, similar to those we experience today at certain intervals. The plasma stream reached Earth around 20 minutes later. It probably took only seconds to minutes for the Earth's magnetic field to become overloaded. The only person who correctly understood the events at the time was astronomer Richard Carrington. The Englishman had devoted himself to the intensive study of the sun, and in September 1859, he saw a strangely dark spot on the sun's surface. The basic principles linking the aurora borealis to solar activity were already known at that time. Carrington also knew that the aurora borealis was particularly strong and had moved southward. The natural scientist immediately passed on the information. However, due to the failure of the telegraph system, people around the world had to wait a while before they learned that it was not the wrath of God that had set the sky ablaze, but a solar storm. After 3 to 4 days, the worst was over. And after a week, the systems were running smoothly again. However, the damage was already considerable at that time, and people were still shaken by the experience. How endangered is the Earth's magnetic field? Did you know that we owe our existence to the Earth's magnetic field, among other things? Without this field, there would be no protective atmosphere, no tides, no climate, and basically no electricity. The conditions on our planet are perfect for the emergence of life, and for the biodiversity we know today. The extent to which we all depend on the Earth's magnetic field is still not entirely clear. We know that animals orient themselves along its lines, and that the Earth's tension probably ensures that vital moisture is kept in the air, for example. Whether or how our organism depends on this is unclear. Mars, for example, has hardly any magnetic field and has therefore most likely lost its entire atmosphere, if it ever had one. The loss of the atmosphere then most likely led to the desolation and loss of all surface water. It's truly fascinating what our Earth's magnetic field can do. The Earth's magnetic field is generated by the perfect interaction of forces inside the Earth. Our planet's geodynamo is driven by the rotation of liquid metals. Processes, such as the Earth's rotation and complex interactions between solid and liquid metallic components, are involved. Convection currents cause the liquid metal to circulate like boiling water, and the movement of the liquid iron generates fine electric currents, which in turn create our magnetic field. The field spirals around the Earth and forms a kind of bar magnet with centers at the magnetic north and south poles. Everything is almost perfect. The interaction between the Earth's rotation, the liquids inside it, and even the protective pockets at the north and south poles is perfectly orchestrated. But there can be exceptions, and these exceptions put us humans at risk. You have to imagine that more violent solar storms are not a problem for our Earth in themselves. It's also not entirely certain how dangerous extreme solar storms would really be for animals if they were not already exposed to disruptive influences from us humans. Birds are confronted with our radio and telecommunications networks, and whales have been proven to react to the echo sounders of ships. If a solar storm is added to this, the animals' navigation systems can be disrupted more quickly. The fact that these structures are most at risk from solar storms alone shows that there is a connection between our radio networks, particle streams, and the magnetic field. Click on the subscribe button now. The best videos are yet to come.